Hello everybody, this is going to be a quick video on ReadWriteLogs, and we're going to use WebStack's course listings page as our example. So a lot of you are probably familiar with WebStack and course listings. As you can see, it's March 29th in the spring of 2023, and a lot of you are probably looking right now on WebStack to try to find courses that you want to take in the spring. So you sort of cruise through and you're like, oh, I hear this Latin American Studies department. They have a lot of really interesting classes. Maybe I can take some of those. Come back over to engineering, you look in computer science, and you're just trying to find out what's offered and what you want to take. And a lot of students are doing this simultaneously. You can sort of see it's taking a little bit of a moment to get that answer back to me. And we would like this to perform well. We would like it to be thread safe, and we would like it to do well. Now, I'm going to show off a couple of different implementations of this. The first one is the not thread safe one. As you might imagine, let's sort of go over to this real quick in IntelliJ. I implement this thing called semester, which forces us to have an add course and courses offered by department. I'm going to keep a list of all the courses in the department. Now, I only have one piece of data in this. It's not hard to imagine. There would also be a calendar of events with, like, you know, Thanksgiving and when the reading days and stuff like that, and a bunch of other things. But for right now, we're just going to have one piece of data, and our two methods are going to work on that. You could add a course to that list of courses. And you know that would be mutating this data. It's that's why it's not thread safe. We can mutate it, and when anyone calls this, when someone else is, or anybody is, some other thread might or task might be sitting there asking for the courses offered by, say, PNP or Spanish or you know, computer science. They're going to use our filter method from before on this list. All this is just going to be reading. Nobody's going to be mutating anything here. So this one is mutating, this one is reading, and that's going to be the purpose it's going to serve for our example here. And so obviously we want to make this thread safe, right? So there's a couple of different ways we can do this. I'm just going to start here by copying over my non-thread safe one to my implicit lock one. That's going to use synchronize to make it thread safe. And this is a pretty effective hammer. I can just sit here and say, make these two methods synchronized. That will synchronize on the object itself, this instance of this object. So whenever anybody calls add course, it'll synchronize on this. No one else, including other calls to add course or other calls to courses offered by, will be allowed to go. It'll be one at a time at that point. So now all of a sudden I've turned my my semester into a thread safe one. That's very nice. What I will say is you could imagine the calendar or other things, like you would want them to work independently. So it's not uncommon, or it's usually a good idea if you have more than one piece of mutable data that could be operated separately on. You could just synchronize on the courses here for these two, if that makes any sense. And then, you know, later when someone was mutating and accessing the calendar, those guys would use that. Now, you could synchronize on this and this. That would be a waste of all sorts of things. You only need to synchronize on courses. So this is what we're going to do. This is our implicit lock semester. It's going to be thread safe, and it's going to be fantastic. What I'm going to do is let's build the explicit lock one just for completeness, just to sort of see what it would look like. Again, I'm going to start with sort of our working version, but instead of synchronizing on courses, what I'm going to do is make a lock. And so private final lock, and that is going to be lock protecting courses. And that's going to be a new reentrant lock. And how I'm going to use this is, instead of doing synchronized, I don't know what exactly I did there. Let me undo that. Instead of doing synchronized, which would use the implicit lock inside of every, you know, that you can access at any object, is I'm going to say that thing, let's lock it. And then we'll do try finally. And I'm going to say this guy dot unlock. And I'm just going to copy this up here and get rid of my synchronize. And I'm going to do the exact same thing down here, but I'm going to put in the filter. And these two versions, one using an explicit lock. Now, is this thing happy with me? Seems like I took out all the synchronized. It seems to have an error somewhere. Where is it unhappy? I have that, and if I save it, what is this thing complaining about? Class or interface? Oh, I have an extra paren. And so this is, both of these are fine versions of the code. I would actually say that this guy is a little more verbose. It isn't really buying us anything, right? Like this guy is using an explicit lock that I made and all this other stuff. This guy is actually a little bit cleaner, right? I'm just synchronizing on the course. The block doesn't hurt me at all. It actually cleans it up a little bit. And so I would prefer to use this one right here where I'm using synchronized on it because this lock, although perfectly fine, is not really, we're not getting too fancy with the spices here. It's perfectly fine to just use the synchronized block. And so we're all good. We've sort of built them both, and we're going to choose this one as our better version. We like it. We don't need this one. And so we're happy with that one. It's pretty good. Now there's a bonus. There's sort of a situation that sort of happens during the semester that we're sort of picking up on, is that now we have our thread safe version. And what actually is happening over this, over the course of time, is this pattern emerges where in January and February, like some poor dude at the registrar office, like creates the new fall semester, like bugs everybody, gets every department to send them what courses they're going to offer, sort of adds them in one at a time, right? And none of the students are reading this semester at all. It's just like this one guy who's like adding stuff. Every now and then somebody looks at it, right? Like very rarely, it's February now, somebody looks up the courses offered by it, right? But there's, again, just like very limited people writing it. And it's not under a lot of contention. It's just sort of going. And then March hits and like thousands of students, right, start asking for stuff. But the department is the registrar is largely done, right? Like there's like all the courses are on there. We've added everything. We've mutated all we're going to mutate. And now it's like time to read it. And everybody's just doing all these reads and nobody is actually changing anything. But like there's all these reads going on. Every now and then somebody has to change their course or adds a new one. Sometimes I have to edit a course later because it's overlapping with something I don't have, right? So there's a little bit of mutation that goes on in here, right? But during a burst of activity where a ton of people are reading this thing, and oh, by the way, this is the time when we want it to perform well, all these reads can happen in parallel. It's only when it's a write that there's a problem, if you know what I'm getting at. And so since there's this thing where data races occur and race conditions often occur where, you have to have more than one task reading, accessing the data, and at least one has to be a write. You can optimize this out where if you have a pattern like this, you can use what's called a read-write-lock. And what that does, when you create a read-write-lock, it makes two locks. They're associated and forever bound together. And if anybody ever gets the read lock and locks it, and if only people are reading, they're all allowed to go at the same time. As soon as somebody grabs the write lock and acquires it, now everybody has to wait, right? Like, so everybody who's reading will finish and then the write lock will be given it. Everyone then blocks for the write lock person to go, right? So in this case right here, in this situation, like when tons of people are going, everybody's allowed to access at the same time because nobody's writing. Here everybody's going, and then say all of these people are working at the same time and this guy comes in and the registrar needs to add a course. Well, these guys are going to wait for a minute while that's done. And then once this registrar finishes adding this course and releases it, then everybody goes back to all reading together and nobody blocking. And so this is a nice feature. Let's go ahead and build what we're going to call the read-write-lock semester. And so back over here, I'm just going to copy this guy because it's got our nice little lock in it over to our read-write-lock one. And so instead of just creating a reentrant lock, let's make a read-write-lock. And this is going to make a reentrant read-write-lock. Now, add course is going to, first of all, like this, I'm going to call this read-write-lock protecting courses. And what I want to do here is I want to use that, but that guy doesn't have a method. This read-write-lock doesn't have a lock method on it. It has two guys on it, the read lock and the write lock. Since this guy is mutating, add course, I need to grab the write lock. So anytime anybody calls write lock, it's exclusive. It's just like the old explicit lock that was calling, straight up lock on that guy. This guy is going to prevent everyone else from going, right? I need to make sure to unlock that guy when I'm done, right? But now this guy is now protected. And down here, I can be like, well, let me get the read lock, right? Because all I'm doing is reading the courses, filtering out the information and returning that. And so now I have a thread safe version that gives me this nice characteristic of, well, if anybody's adding courses, well, we don't have to wait for that guy to be done. But if all of us are just reading all the time, which is, then I get this beautiful, wonderful performance, and it's sort of the most important time. And so this is not an uncommon pattern. It's sort of very reasonable and common that there's a burst at the beginning where you fill up this database with all the information, and then it goes into the situation where everyone is accessing it all the time, but they're just reading it, with the occasional time when someone has to come in and write it. So you need to be still thread safe. You need to have this ability to shut it down in case anybody writes. But if you have one of these patterns, you can get a lot of performance improvement and at the most critical, sort of performance time by using read-write locks. And so hopefully this has been helpful. We will be using read-write locks in exercises in this course.